But good morning, good afternoon, good evening to wherever you may be across the world. Thanks for joining us live here on Serverless Land. Super happy to have you. My name is Julian Wood. I'm a C developer advocate, and I work within the serverless product team. And I've got two excellent guests I'm super happy to introduce to you today. Let me just bring my screen up so I can get their names. You know exactly who we're talking about. First of all, we have Principal Product Manager within Lambda, Sushant Bhatia. Sushant, welcome to Serverless Office Hours. Is this your first time on Serverless Office Hours, or are you a veteran? I'm trying to remember.
No, this is my first time. Thank you for having
excellent.
me.
Pleasure. I get the one to welcome you. Thanks so much. Thanks so much for joining us. So, Sushant, you've been in AWS? I think it's just been 4 years. Literally just been 4 years.
4 years this month.
Wow. And where have you sort of come from beforehand, and what has your interest been? I know within Lambda, you're deeply involved in bigger, better, faster, more, and doing more sort of cool stuff on the Lambda side, which we're obviously going to talk about today. But yeah, where have you come from before?
Yeah, I was on Alexa for Business for about a year prior to joining Lambda. So I've been on Lambda about 3 years now. Prior to Alexa for Business, I was working on cool CDN and edge of network technologies for one of the other folks across the pond in Seattle.
I wonder who they could be. Cool. That's cool to know. So you've come from a networking side to Alexa and into Lambda. That sounds like an interesting pathway.
Yeah.
And then second up, we've got Michael Kavanagh, who's a senior software development manager, and he's based in Dublin, which you may be able to guess from the accent shortly. Michael, welcome to Serverless Office Hours 2.
Thanks very much. Thank you, Julian. Thanks for having me.
No, thank you. And Michael hasn't been in Lambda for that long. I think it was just over a year. And we were just talking offline saying anytime in AWS, well, I suppose maybe Amazon and other big companies as well, 1 year is probably like dog years. And it probably feels like a little bit more. But Michael's parachuted in to help work on the compute substrate, in the middle of a pandemic. With 8 hours time zone difference between people like Sushant and yourself. So I'm sure that must be a fun onboarding, but yeah, well done on all the stuff we're going to talk about today that you've been heavily involved in.
Thank you. It's been, a neat experience. It's different and the same in many ways. Starting from scratch from another time zone isn't a new experience from my position, so thankfully it's somewhat of an acclimatized start. But yeah, low-level compute is new, although performance tests and optimization is very much a known thing from my previous companies.
Cool. Well, nice to have you along. So just looking back sort of in the past before we head on to what we're going to be talking about this week, Serverless Office Hours, as you may know, runs every single week. And last week we had Serverless Surprise, and excellent co-host Eric Johnson spoke to Ben Kehoe. And if you don't know Ben Kehoe, he's one of the brightest, cleverest people I know, certainly in the serverless community. He works for Roomba as iRobot, as a last week was all literally about security, the snappy title of Serverless Security and Suspenders, because Ben wears suspenders. But really, Ben goes crazily deep into all security things and some really cool tools that he's built to help you with security. So head off onto the Serverless Land YouTube channel, youtube.com/serverlessland, and you'll be able to pick up that episode and many of the past episodes of Serverless Office Hours. So just a quick look over the past week or so, what's new in the whole world of AWS Serverless and some sort of adjacent services. DynamoDB has a NoSQL workbench, which helps you to model and do some clever things. And that allows you to now automatically populate some sample data, which is cool. If you're into streaming workloads with Lambda, then Lambda also now supports IAM authentication for Amazon MSK as an event source. And this makes me super happy because anytime you can use IAM and you don't need to use any other kind of authorization, makes me super happy because that's just so much simpler. Also, Lambda had a really cool thing about triggering Lambda functions from an SQS queue in a different account. Just makes it so much easier. Also makes it more secure as well. So that's going to be far easier if you are connecting Lambda and SQS. And then I'm sticking this on for another week because it's so awesome. Step Functions has added support for over 200 AWS services with SDK integration. And this is just really cool. And I may have to ask Sushant and Michael to close to block their ears slightly because I'm going to slightly hurt their feelings things, because this means that you could probably rip out some Lambda functions from your application. But in a way, that's a good thing. If you're just using Lambda functions to be able to move some data around and just to launch something from anything within the AWS SDK, now you can possibly do this directly in step functions, which just makes it a little bit more robust, less code to monitor, something less to worry about, and you can reserve your Lambda functions for the workloads that really need them. So that's a super good release that's come out, and I love the idea of just having a universal SDK runner that can do all these cool things with anything on the SDK. Just looking back over blog posts, the Q3, in case you missed it, post James Berzer put out, which is all the serverless content over Q3, and there's a whole bunch of it. So if you want a quick look and find out what's been going on in the world of serverless, please head over there. Talking about Step Functions Workflow Studio, or Step Functions Workflow Studio is another part of that where you can graphically build step machines. And this is a really cool blog post that has been put together, simplifying B2B integrations. Then Jerome van der Linden has got 2 blog posts out of what's developing into a series, something that I'm super interested in. And this is all about operating serverless at scale. And this has got a whole bunch of tips and tricks and information on how you can do governance and things like tagging policies and resource management and a whole bunch of other kind of things. And then consistency, being able to use cookie cutter SAM templates. Sounds all weird and crazy. We're talking about cookies and Lambda. But yeah, really useful stuff if you sort of not just building your day one application, but you're going to be keeping it around and it's day 2 operations kind of stuff. And at scale, this is super useful. And then just the last one, James Berzer again, avoiding recursive invocation with S3 and Lambda. This is a super important one because it's one that can trip you up, not necessarily simply, but it's something that can trip you up when you land up getting the bill and you're like, what on earth, how on earth did that happen? And this is just some tips and tricks that you can use, from naming your S3 buckets and naming your objects and using filtering and things like that. So you don't have the scenario where S3 triggers off a Lambda function, Lambda then puts something back in S3, and that just cycles round and round and round. And I'm sure Michael, as dev under the Lambda team, sees all the flashing things going red and panic going on as Lambda recursively calls itself. So this is useful to be able to sort that out. But today, the star of the show is a new functionality that has come out, which is Lambda running on ARM Graviton2 processors. I don't want to preempt anything that Sushant is going to say, so I'm going to switch over to Sushant's machine. And Sushant, tell us, what is Graviton? What is ARM? I'm presuming people know what Lambda is, at least.
Yes. Well, Lambda is something that a lot of people already know about. So I'm going to say that is a given. But let's talk a little bit about Lambda functions powered by ARM, by Graviton2. And specifically, let's talk about what is Graviton2. So, by the way, is my screen refreshing?
Not yet. We still got the titles on. So there we go.
There we go. All right. So the Graviton2 processor is the custom AWS silicon that is based on the ARM Neoverse cores. It is something that we have built. The Annapurna team has built actually to be optimized for cloud and cloud-native workloads, and it is something that we have heard from customers as they've seen the benefits on running that in EC2 and instances and other kinds of services that have already supported Graviton, and customers wanted to bring those same savings and performance improvements to their Lambda functions as well. And this is something that we felt, it was just something that it was a peanut butter and jelly, or whatever the equivalent is in any part of the world. It just goes so well together. So what do you get out of something like Lambda functions powered by Graviton? Well, you get up to 34% price performance improvement. It is something that is priced 20% lower than the same size Lambda x86 based functions, and it is going to give you the highest performance versus the x86. Now, I'll caveat that, and we'll talk a little bit more about what we mean by the highest, like the up to and the highest performance, because it is going to be workload dependent. You are going to want to test your workloads. You're going to want to measure it. You're going to want to use the latest libraries. You're going to want to use the compilers that are tuned for building for ARM 64 and so on. And more on this cool stuff later on, and I'm sure Julian and Michael will talk a little bit more in detail about that. So the launch that we had on the 29th of September allowed customers to choose the architecture between x86 and ARM64 for the workloads, for the functions that they're running on Lambda. And specifically, what a customer gets is the ability to take their code and say, I want you to run it on ARM, or I want you to run it on x86. It's that simple. That architecture flag, as it were, comes into play. So transitioning to AWS Lambda functions from x86, well, there's a couple of things you want to know about this. In the interpreted world of code, you can run it without any modifications. So if you're Java, Python, or Node, you should be able to run that by just making that flip on the architecture, unless you have any native dependencies. And those native dependencies would need to be compiled and deployed to run on ARM.
So Sushant, just jumping in there, and I know I'm playing a bit of devil's advocate because I have looked at this and it is cool. For a lot of functions, customers literally just toggle it. They just go, do you know what? Today I'm going to test my Lambda function running on an ARM processor, and they just literally make a config change. There's obviously multiple ways that you can test it. We're going to go into that shortly as well, but they could run maybe faster, definitely going to be a little bit cheaper, and that sounds like a great win all round. So it's not something that people need to be freaked about trying. There's a lot of stuff that you have to do very little for. And then the next stage, I suppose, is, well, if you've got some dependencies, but if they're non-compiled, they just Node modules or Python modules or something that aren't architecture specific, well, they are just going to work as well. Is it that simple? Cool.
Yep, simple. And a lot of tools, as you mentioned, there's a lot of tools that already support Graviton2 transparently. So, the CLI, V1 and V2 already support that. There are SDKs that we have for C++, Node, Python, Go, Java, .NET, etc. will all support these as well. In terms of what we support for the languages and runtimes, we targeted all the AL2, Amazon Linux 2 based runtimes on Lambda to be able to use the new functionality. So Python 3.8 and 3.9, Node 12 and 14, Java 8 and 11 on AL2, .NET 3.1. We're very, very happy to see. I am a former .NET developer. I did that for a long time, and I've worked and I love C#. So I was very happy to see that myself. Ruby 2.7, and then obviously the OCI-based images and the custom runtimes will also support this. So we'll talk through the migration. I think, Julian, you're going to do a bit more of the migration. So I'm going to kind of just quickly go through and say, migration is as simple as Julian said. You got to try it out, see what the effects are. There's some interesting A/B testing capabilities with versions and aliases that you can use that Julian will probably talk about as well. And then, if you need to go deeper, there are things that you can do by looking at all the libraries and dependencies and compiling it. More and more, I think it's important to basically say, test it, validate it, compare it, and then make sure you're using the latest versions of the libraries and runtimes. Because from our testing, and Michael will talk a little bit more about the kind of the benchmarking side of things, but from our testing, we did see that using the latest versions tended to be a lot more performant. The other really interesting call out here for folks, if you're getting started with Graviton, building for Graviton, is to go to this GitHub page where the Graviton team kind of collects a lot of the learnings that they've already put together on how to work with Graviton, how to have CI/CD pipelines, what libraries and runtimes and everything else works together with Graviton, and go use that as your source as well. So you can go look at those. It is really, really cool. They continue to keep that updated, something that you want to probably star and keep track of. I would also say that, many thanks to our launch partners who came up and did the blog posts and also supported Graviton in their launch as well. So Handstack, Checkpoint, Cloudwire, Contino, CoreLogix, Datadog, Lumigo, Pulumi, Slalom, Sumo Logic, Tandera, and Xeris. lot of cool stuff. You should go check it out. They've written some excellent blog posts that talk about their experiences with Lambda and Graviton and the process of moving over. So really recommend that. And so in summary, I would say, what we've kind of covered here is, with Graviton functions, you should be able to get up to 34% better price performance improvement. Even if you don't see a performance improvement, you should still be able to, if they're on par, you should still see up to 20% lower cost. So it's kind of a win-win to at least try it out and validate what you're seeing.
Sushant, can you just explain, because we do use the term price performance, and obviously that's two different words in the same sort of phrase. How should people understand what price performance means? Because obviously there's a price component and a performance component. How do they fit together?
Yeah, so price performance is something that kind of is an interesting wording or verbiage. There's the component of how much do I get for a certain amount of performance or price out of that performance, and that's kind of where this kind of comes from, the way to compare compute. It's one of those older things that has existed for a while that we've kind of used as well. It marries both the performance improvement and the price change to give you a number that is more tuned to kind of what the maximum that you would see is. So here, you're seeing about 20% performance improvement and a 20% price improvement. So we've lowered the price, and that gives us the 34% better price performance improvement there.
Okay, so when people are looking this, even if they don't get any better performance with Graviton, and there may be very valid reasons for that, it's already cheaper out of the bat, 19 to 20% cheaper. So that's already a cost saving, even though you may not be getting any price performance. But
that's right.
With the way Graviton works and some of the special functions within the CPU, that also means that in addition to being cheaper, it's also your functions may run a little bit faster. And so because Lambda bills in terms of compute time, you can also save money that's how you save money on the performance part of it.
Correct. Yeah, it is something that we think that customers would get a lot of benefit out of, especially for the different kinds of workloads that they could run here. Web apps, microservices, data processing. There's a bunch of these workloads that we think that customers will get a lot of benefit out of. If you're doing CPU intensive workloads, that's another one that I would say you should definitely look at. Graviton 4. And we've seen some improvements with scikit-learn and those kinds of things as well. So some interesting things going on there.
Just to then switch it around, what you've mentioned some good workloads that people should try. Obviously, I'm going to suggest you try any of your workloads because it's simple. I mean, it's simple to try. If it doesn't work for you, it doesn't work for you. But what are the kind of workloads that maybe won't be a good fit initially that people shouldn't bet their whole future salary on moving off x86?
If you're taking advantage of any x86 instruction sets that they don't have a parallel in Graviton, then that's something to watch out for. Something like if you're dependent on AVX 512, which Lambda today doesn't support, but if you were using that, then there isn't a comparable right now, I believe, on Graviton. So that isn't really something that you would be able to leverage there effectively. Other than that, there are some instruction sets where I believe x86 will combine multiple instructions into one. And so, that benefit there will be where x86 will shine.
Okay.
I'm tongue-tied there for a second.
Excellent. Yes, I just want to bring in Michael as well, because Michael has been literally working deep in the weeds of doing some of the performance testing carried out to date. What would you like to add? What kind of, in fact, talk us through the sort of the approach even to the performance testing, and then you can finish off with maybe some, customer ideas of what they should be thinking about.
Sure. So to start, we started out very naive. So I think it's clear, even with people who are doing this for a long time, that everyone should take this on with as much 360 coverage in your testing as you can possibly achieve. Even very experienced engineers here took I would say, one-dimensional linear approach early on to what performance benchmarking would look like whenever we started the project. with a lot of humility and questioning, those engineers moved to the adoption of a more well-rounded coverage, and we engaged with the benchmarking team here at AWS as well to get further coverage. So that journey was difficult, and it was pretty enjoyable for people who want to geek out on performance. If you take something like a recursive Fibonacci, which a lot of the comp sci's will remember from their mathematics classes in college, those are great tests for compute, but they're terrible at really determining overall compute on a box, because you get a lot of caching that happens. I'm not going to go into the full comp sci 101s here, but what I would say is creating as much variance in your test suite as possible will give you better coverage for the performance that you expect to see in real world from your functions working in Lambda. So if you kind of draw a single test and say that's it, you're most likely to see variance that is unexpected, potentially to the negative from your expectations. So we built out an entire test suite. We ended up doing tests across all of the runtimes available that Sushant mentioned earlier. We even ran them against each of the instance types that were available, like the M6 GDs, the R6 GDs. Then we started looking at form factor of the CPU allocation on the boxes and things like that, in the end, we thankfully didn't have to go that far with it. But to give you an idea of, it is the first time recursive Fibonacci has ever been said. I've been muttering it in my sleep for months, but there are a bunch of other tests and real world test cases that we ended up going, then migrating from what we would refer to as synthetic tests to real world tests. So the synthetic tests were super for the on metal instance comparisons of what we expect apples to apples to be. And even then, they weren't completely appropriate. So whenever you take something like a real world example, a scikit-learn test suite that Sushant alluded to, whenever you try to do an evaluation of Intel M5 GD to an R6 or an M6 GD on Graviton, you have to take into account the compilation of your supported libraries. So if we had SciPy, it needs to be recompiled, but you also have to recompile it for the Intel tests as well, so that you have a true apples to apples with the same compilation process. If you just take what you previously had, you're not testing the code difference, you're testing the efficacy of the compiler used. So those are small notes that I would encourage everyone to try and take into account and think with as much scientific method as possible before just going down the road of flipping the switch and going, oh, this tanked, this was terrible, because you potentially are missing out on a up to 34% price performance improvement for the same workloads that we're really delighted to have gotten to replicate in real world workloads by performing these same steps.
No, thanks. I just want to jump in there, and for people, because this is serverless office hours, Michael was talking about M6 and Gs, and those are things called instance types, and those are, you may not have heard of them, but they are the servers that are actually in serverless. And if you're watching this on serverless office hours, you normally don't need to care about it, and that's one of the awesome things about serverless. But this functionality, some people have also said, well, hang on, why are we needing to talk about Intel and ARM and CPUs in terms of serverless? Surely that's not something we need to really think about serverless. So if you were confused, then the M's and the G's and all those kind of things are different instance types, EC2 names that you can do. And basically, Michael's talking about the real sort of hardcore bare metal performance characteristics and testing you can do to really make this magic. Because I suppose, Sushant, you can butt in quickly if you want, but I suppose the point of this is, if we don't do this and we don't highlight the difference between Intel and x86, you're not going to save money, and that's not something we could have just done underneath the scenes, because you do need to recompile some of your code, and that would be bad for customers. You'd be very annoyed one day if Lambda under the hood was just upgraded to ARM and your dependencies broke. So yeah, we're bringing some of the servers into serverless, but as little as possible to be able to give you some cool functionality.
I think that's right. I think we're kind of giving a peek under the hood today, just to give customers a view of kind of what it took to be able to get this out there and be really happy to say you can actually save money with this. We've tested this, we've done this. Where you obviously got to test it with your workloads, but for the ones that we tested, we did see the improvements there. I think the main other thing to take away here is, as Eric says, there are servers and serverless, but you don't have to care. And the main point that we want to also pass along is how you think about this in terms of the x86 and ARM. We want to make sure that we're giving the capability for customers to understand that if we did this behind the scenes without folks knowing about it, things could have broken. And for us, that is not a good thing to do for customers. It's not customer obsessed. We want to make sure that customers understand we take things very, very seriously. We're not going to try to break you. This is more kind of a way in the path, as it were, for us to be able to give the capabilities that customers need, so that we get more and more of the tooling and the kinks and everything else ironed out in the way that various libraries and runtimes are supported.
Well, I think as well, the point that I'm probably trying to get to, probably more server talk than I should be getting there,
Not at all.
is that you can just change your code to flip over to ARM and it'll work. So that's super. Then you can go to flipping over, and if you have a managed runtime that you expect to see a huge price performance with, you may get it depending on the compilation against that runtime, right? But if you don't get that, I would say don't just stop and just say, well, that was a waste. This isn't going to work out for me. What I would say is iterate on your testing scenarios, look at the coverage there, look at the compilation process, and really compare the apples to apples whenever you've exhausted your entries. Whenever you get to that point and you still don't have the price performance improvement, you probably only, whenever our engineers did it, it only took a day of effort really to do that recompilation and have an apples to apples comparison. So it's not a huge cost for you, but it could make quite a difference in the potential savings that you would have left on the table had you not taken that effort.
So
yeah,
getting started.
One other thing. Sorry, Julian. One other thing to add is, as you folks do that, if you follow that approach that Michael has laid out, this is the same thing we used, by the way. If you use that approach and you still find that it's not quite where it needs to be, reach out to your TAMs, reach out to kind of your account teams, and have them engage with us and the Graviton team, and we'll go look at some of these things to see if this is a known thing or this is something we need to add into the backlog for support or something to do. So please let us know what you're seeing.
Yeah, we've got an interest to make the as performant as you can, and there's a whole Graviton team who work within the EC2 organization, and they love to highlight how Graviton works, because Graviton's an AWS made processor, so we're super invested in making that work as well as possible. And as Michael perfectly says, I think you move your functions over, you can move them very easily. Yes, it's going to be cheaper, or generally going to be cheaper and better price performance, but with a little bit more work, either going from new software versions of a dependency. So that could literally just be, doing a new npm install or a pip install and seeing a newer version of some library that could immediately give you a performance boost. And then further workloads, if you've got specific number crunching workloads, as Michael was talking about, the scientific libraries and those kind of things, the ARM ecosystem is working like crazy to be able to have better and more improved support. So that's going to give you even more price performance. And as we get more streaming workloads and as we get more big data workloads running on Lambda, those are scaling up to some sort of huge, significant workloads and parallel processing that people are doing. And yeah, that's going to save you time and money, which is going to be awesome. Yeah. Cool. I think any other, we did have a quick question, one or two questions I will just talk about. Is there a resource for finding if NPM and pip packages work on Amazon Linux too? There is, if I can find, there's actually this website, which is called, let me bring that up as well. If I've lost it, pkgs.org. So that's actually a website you can go to, and you can look at different whether there are ARM available packages. So that is super useful. Then thank you for that question. And then Joan Zachariah Noel says you can add the npm packages as layers. Whenever creating the layer, you need to specify the architecture as ARM. yes-ish, no-ish. If the Lambda layer is just files, remember, if there are no compiled binaries and it's only basically text files, maybe that's for Node or Java or Python, you don't actually need to specify the architecture as ARM. If you do have binaries, or you do have specific maybe Lambda extensions written in Go, or some binary that runs in a Lambda layer, you can specify a compatible architectures within your Lambda layer. So you could specify that as an ARM compatible layer, and then you won't be able to add that to an x86 function. So you may not need to specify the architecture, but there may be use cases that you do want to specify the architecture if you do have any binaries.
So just a small clarification there. So I would say you can, if the library is both for x86 and ARM, you can say the compatible architecture is x86 and ARM. It'll make it easier for whoever's searching for that. If you're in your account or whatever you're searching, it'll help you find those. The other thing is we made the decision not to prevent people from adding the libraries that are x86 to their ARM functions, or vice versa. And that was specifically because we said, look, at some point a customer has to kind of know what they're doing and what they're trying to do. This is just an indicator for customers to know whether it is or not. But at the end of the day, we're all adults. You know what you're doing. Go for it.
Yeah, we don't force that at the control plane in any way, shape, or form. No, thanks for the clarification for that. Thanks. AJ Stivenberg says, well, first of all, you agreed with me, so that's always a good start to a question. Switching to Graviton was mostly a config change for the vast majority of functions you're running, and it was basically it was worth trying basically everywhere. Well, that is super cool. So I'm going to jump into some demos. Seeing we've been chatting for some awesome stuff, and I love the background information. Have I got the right screen connected when I'm hosting and doing the demos myself? It's all a bit split screeny over here, but let's go through I'm putting air quotes here, the sort of complicated process of what it would be like to actually create a function with Graviton. I'm joking, it's ridiculously simple. So I'm in the Lambda console. I'm just going to author a function. I'm going to go my happy without a space. And I'm just going to say Node.js 14. I could have picked Python 3.9 or anything.
Hey,
and yes.
I can't see anything. Are you sharing your screen?
I think so. I can see it on my side.
Yeah, I've got it on my side too.
Okay, just me then.
Okay. No, thank you, Sushant. Otherwise, that would be rather silly. So what I'm doing is I'm just literally going to select that I want an ARM architecture function, and I'm going to click on create the function. And basically, in the background, Lambda is going to then create a new Lambda function, which will then run on Graviton instances. And just one thing to mention, basically, x86 servers and Graviton servers, they're completely, separate servers in the back end. So I know we're not really talking about servers, but these are completely just sort of separate parts of the fleet that's actually going to run on the background, just for your information. So what I'm actually going to do is I'm just going to, once the code source pops up, and apologies, it is slow while I'm streaming, but it will get there, and my happy little function is going to appear. So what I'm actually just going to do is I'm going to use an operating system call, which I'm going to edit the code, and I'll probably paste that twice. And I'm going to then do a console.log, because I could talk about the processor architecture. And what I could do is just say the response from my Lambda function is also going to tell me what the process architecture is going to be. If I was to deploy that Lambda function and I was to test that Lambda function, I don't need to call my test anything because I've got anything going over here. And off I go. And if I then, ooh, my screen's going nuts, it's really big. And if I test that Lambda function, there it goes, my Lambda function, hello from Lambda, and that is running on ARM64. So I've literally created a Lambda function. I've specified it's going to be ARM64, and I have then outputted what that, from the operating system, I've then outputted what the process architecture is going to be. So I've sort of done this the other way around, but what I can actually do is I could just literally switch this back to an x86 function. I don't have any dependencies. I've got no binaries. I haven't got anything complicated within this function. So what I can literally do is just save this function, and I can literally just run the same test again. I haven't had to make any. Where's my test? I haven't had to make any other changes or code configurations or do anything. And it's slow on the. It's a bit slow on my browser, and I click with the same test event source. There's the test. And there we go. This Lambda function running on x64. I've literally switched quickly between the Lambda function running on ARM and the Lambda function running on x64, and the console has told me exactly what has been going on. So that's number one. Now what I've got is I have another Lambda function which has got some dependencies. The dependencies aren't a lot. This is just running. It's got a dependency here called Axios and a particular version of Axios, and Axios just goes out and is able to pull things from an external API. Now, what I do have is I have a Lambda function here, which is configured using SAM. Now, AWS SAM is our serverless application model, and this is a way to use CloudFormation on steroids and be able to build serverless applications. A cool few things that I can actually do with SAM. First of all, this Lambda function I'm going to build, and I have deliberately set the architecture set to x64 initially. What I can do is I can, if I wanted to change this Lambda function to ARM, all I specifically do in the SAM template is say I want to do an ARM function. So I'm going to save that. And what I'm going to do is then I'm going to build my function. So I'm just using the SAM build command. And what this then goes, it goes looks at this package.json file. It is then going to install those dependencies and build my Lambda function. And you can see here it is read. It has understood that this is an ARM function, and so it's going to build an ARM function. Now, you may be wondering, if I did have a dependency that was going to be some sort of binary, how on earth am I going to build an ARM binary on an x86 machine? Number of different ways you can do that. First of all, you could use an ARM machine. So something like an M1 Mac, you could use an ARM machine and you could build a binary. Or what you can actually do is you can connect to an EC2 instance, or maybe even a Raspberry Pi, which runs on ARM. There are going to be a lot of different ways that you're going to be able to do that. But I'm on x86. I'm not going to go and buy myself an ARM-based device to do that. So what I can do, and this is part of the cool things with SAM and with Docker, is I'm able to actually build using Docker or using SAM as a container and using an ARM container to build and compile my Lambda function. Now, I don't have any dependencies in this one, so it's a bit of an artificial test. But if I did have dependencies, something like Go or Rust or something that I did need to create a binary, this is basically going to build the artifact within a container, a Docker container, and that is going to be able to then build an ARM native binary, even though I'm running on x86. Now, this is obviously taking a longer time because who knows, the things are going weird, but anyway, normally, there we go. So we can actually see that this is what this does is this then fetches an ARM Docker container from the public ECR registry, and within that Docker container, that Lambda function is going to be is going to build. So that's going to be super easy. So it's taking a bit of time, but once that has done, if I did have a binary dependency, that would be built within that Docker image. But I haven't had to specify a Docker file. I'm not doing anything with Docker really in this point of view. All I'm telling SAM is that I've got an ARM architecture function in the background. SAM is doing its magic, and it is working really well to be able to build that dependency. That is taking some time, but what I would actually then do next is I would then deploy that SAM function up to AWS and what's that go up to Lambda, and what that's going to do is then that's going to behind the scenes copy up. This is a zip archive function, so it's going to set it over there. It's going to then create the function within via the API, and it's going to set that to an ARM function, and I can run it just as I did before. So that is what I can do over there. I have actually pre-deployed this, so let's pretend that I have deployed this Lambda function. And with the SAM template, it does actually sit behind an API. So it's got some funny kind of stuff. And this is just a number generator. And what it's going to do is behind this API, it is sending that request, and it is telling me that December the 10th is the day in 1665 that the Royal Netherlands Marine Corps was founded by Michiel de Ruyter. That's using the Axios dependency within the Lambda function to go to a third-party service to pull something out. And this function is running in as x64 because I haven't deployed it yet. But basically, I've just pulled down the header for this function. Let's see. That's taking a very long time to build that Docker container. Maybe something to do with while I'm streaming, that maybe Docker's spinning its wheels in the background. But anyway, you are going to have to believe me for this. I would have uploaded that function. It would be ARM64, and I'll be able to run it with SAM. Then what I can actually do as well is I'm going to actually have to need to wait for that build to happen. Let's see what I can do at the same time. But something that you do want to do is maybe you want to test your function locally. And again, this is something that you can also do because of the power of Docker and SAM behind the scenes. What I can actually do is I can do a SAM local invoke of this function, and I can just pass it a test event. And what's actually going to happen is this is then going to spin up also another Docker container, which is an ARM build of the function, and I'm going to be able to test this function locally. So this means I can do really quickly. Here we can see the ARM64 function. Maybe this is going to take time, a lot of time as well. But anyway, so this allows me to do local testing of my ARM Lambda functions on x86 just using SAM. And that's going to be super easy. So this is a way that you can really iterate, and you can build your Lambda functions, do your local testing to make sure that all your package management is working and that your dependencies are there and your Lambda function actually works. The other one still hasn't mounted, and this one is going on. Anyway, demo. Yeah, what can you do with what can you do when there are demos? So now, SAM may not be your thing. Maybe you want to do things purely in Docker. So what you can do is I could build this exact same function as a Docker image. And so what I've got is I've simply got a Lambda function over here that's using the same numbers API, which I give it a number, uses Axios, and gets something back from that. So forget we've done anything SAM. I now have a Docker file. This is maybe an existing Docker file I have, and this is using the Node.js. It happens to be version 12. I could have done Node.js 14 or one of the other versions. And this is just going to build a Lambda function, and this is going to build an x86 Lambda function as it's done. But if I want to switch it to ARM, all I'm going to do is update the base image layer and say I'm going to build Node.js version 12-ARM64. And that's literally all I need to do. So what I would then do is I will build this Docker file, and hopefully Docker's going to maybe behave a little bit better without the SAM part of it. There we go. So just using the Docker CLI, I'm able to build a container image function containing this Lambda function, and that is then it's going to pull whatever it needs to do down from the ECR repository from Node, and it's going to add the app. It's going to add the application file and do the npm install, and it's basically going to install this in a container image. Once it's done, and hopefully this isn't going to be ridiculously slow. There we go. It's doing its thing. I'm going to speak over this because it's all, of course, when you do this beforehand, these take seconds, but that's how it sort of works. If I then was to inspect this, if I was to then use the docker inspect command, I can see I have a local Docker image running on ARM64. So what I can also do is I could run this Docker image locally. So I'm just going to do a Docker run, and that's going to be running that ARM container locally. And then what I can simply do is I can just run that same test, but I'm not doing anything SAM. I'm not doing SAM local invoke. I'm literally all within the connection refused. That's nice. Oh, it hasn't quite started yet. So what I can do, if this does work once it's up and running, yeah, Docker's taking a little while to get going. But basically what I can do is I can test this whole Lambda function purely within Docker, even though the Lambda function is running in ARM, I'm on x86. How cool is that? Docker can be super cool with that. Let's see. This would be nice to get working. Please, please, Docker, tell me you can do something. Holding thumbs. That looks better. We haven't not failed to connect. but basically, this should then connect to the Lambda function locally. I haven't done anything to be able to do. There we go. It tells me about August the 21st. I haven't had to do anything, and I can do my local testing just as I've done before, but now on ARM. So what I can actually, if I wanted to, is because I can then tag this image locally. I can log into ECR and I can then push this image up to the ECR repository. And then what I could go and do is I could go and create a Lambda function from this image. And by magically, I now have a Lambda function built from a Docker image that will then run on ARM. So as Sushant was saying earlier, I'm not going to show that just in the console because we are running a bit out of time. I've got a context. Some weird errors while timeout exceeded while awaiting the headers. That seems a little bit strange. But anyway, there we can see that the Docker layers are then being pushed up to ECR. And I can go create a Lambda function. And I just go and select, I want this Lambda function built. In fact, I can show that because that isn't going to be too complicated. Where were we? This was the happy function. If I go back to my functions, because it is quite nice to actually see this in the console, how it can also browse easy to see what that function is. I want to build a container image function, and I want to do it on ARM64. I want to browse an image repository, and I think I called Docker number R. No, that can't be that one. It hasn't quite pushed up. Anyway, that would be a few seconds ago. I think I don't have a different image. And I select that image and I go and create a function. So purely using Docker, haven't need to use SAM at all. I've been able to create a local Lambda function with ARM dependencies, could be binaries, could be anything, able to locally test it, push it up to ECR, and then be able to build a new Lambda function that is based on the ARM instruction set. So there we go. That's how we can do it with Docker. Now, another to do, and as Kevin and Sushant have been talking about, is how on earth do you then compare your Lambda functions? Well, of course, what you can do is you can build your Lambda functions. You can have two different versions of them, and you can then run the Lambda function and then try and work out what the sort of cost differential is, and do this all for various iterations of your Lambda function. That's going to be a pain. That's not going to be particularly simple. So I don't know if you have heard of this yet, but a really powerful tool is called the Lambda, AWS Lambda Power Tuner. And this is a super good way using step functions that allows you to run multiple invocations of your Lambda functions with different memory, and you're going to be able to then graphically see that. So what I do have is I have two Lambda functions over here. Let me just close these so I can make a bit of space. And basically, this Lambda function is just so I do want to delete that just to make a change. And what I'm going to do is we got an error. I'm going to build, I've got SAM, I'm just kicking this off and then I'll explain it. I've basically got a SAM template and I have one source folder. So one code URI, and I've got one Lambda function, which is going to be ARM64, and I've got another Lambda function that's going to be x86. And I have a build failed. Can't find Python. Can't find Python because I was meant to use the use container. I don't actually have Python installed locally. But again, I can just use a container, and that's going to pull down two different containers, actually, and it's going to build one function for ARM64 and another function for x86. Two Lambda functions going to be built super simply, and this is now then going to download. Of course, because we're living in the Docker world while we're streaming, this seems to be taking an absolute age. Actually, not too slow. That doesn't look too bad. Let's see. We've got an ARM. Maybe we'll wait for a second. So what SAM is doing behind the scenes, it is pulling down, building the ARM function. You can see it's actually using an ARM container to build the ARM function. And then what's going to happen is it's going to repeat the process, and it's going to pull down an x86 container. There we go, an x86 container that is going to build the x86 function. So I've got the same source code, two different functions. I have this idea that I want to migrate one Lambda function from x86 to ARM. This is one of the ways I can do it to build these two different Lambda functions. So there we go. So I can then literally deploy that up to the cloud, and that's just going to use the SAM deploy, and it's going to add to do the Lambda functions. So if I head then into the correct console, I now have step functions over here, and this is the step functions state machine. And what this is going to do is this is going to run in 10 iterations of my Lambda function with all different memory configurations, and it's going to tell me how long they're going to run and how expensive they're going to be. So I'm going to start a new execution. I'm going to, this is the input to the state machine. Not particularly complicated. This is the on of the x86 function. These are the memory values I want to do, up to 10 gig in memory. I want to run 10 invocations of that. I want to run it in parallel, and I want to compute prime numbers. I think that's, what's that, 1 million, something like that, 100,000 or 1 million prime numbers. And, invalid JSON. How can you do this to me? What have I done? That wrong. Seriously, invalid JSON. That's just because I have two. Sorry, my copying and pasting is going off the screen. Let's try that one. Basically, this is now a step function that's going to go through and tell me what my Lambda function is running on x86, how long it's going to take, and how much it costs. So I have that other function which is running, which is up, which was deployed by SAM. I'm going to start a new execution for that, and I'm going to then give it the. Well, you can do it. You can. Oh, sorry, we're taking some time to clear out. And so this one is going to literally run the same performance test, and yep, this is going to run on the ARM function, and that is going to execute. So if I was to then look at the step function workflow as that runs, in the background it is using some cool parallel processing. You can see there's an executor that was running and is just finished, and that has run in parallel all those different memory parts of that Lambda function for x86, and I've now got the same thing which is running here in parallel for ARM. So how's it going to help me? Well, the cool thing is has this not run? At the end of the execution of the step functions, what this does is very simply pops out a URL which tells me what the report can be. And I can just simply use that URL. Load, maybe it will. This URL eventually. There we go. So this has showed me now I have an x86 Lambda function. If I run it with 128 meg of RAM all the way up to 10, this red line shows me the invocation time, and this blue line shows me the invocation cost. So immediately I can make a data-driven decision to go, okay, the invocation cost is pretty static until about 2 gig, and then starts to ramp up. Maybe even a 3 gig, it's not particularly more. I then literally know that what's my drastically reduced over here. That looks cool. So that even for x86, that's a useful thing to do. Now, what I can do with a new AWS Lambda power tuning is I can now compare it to another invocation. So this is I'll open the one specific for ARM, but just for the benefits of time, we can actually plot them on the same graph. And this is the ARM comparison. No, it's not. So that's what I was expecting to see. So basically here, I've just compared it. I now have the invocation time in red as we had before for the ARM function. Remember, it's a CPU-intensive operation. It's computing prime numbers. May not be indicative of all workloads. We're not all computing prime numbers in our Lambda function, but this is what you can do to test. And look here, I have invocation time for x86 and the invocation time for ARM. And immediately you can see it's already faster. So I already know for this workload, my ARM function is going to be faster from an invocation time. So on that price performance axis, the performance, I'm already winning. But look here, look at the invocation cost. And I can see over here, compared to my x86 and to my ARM, I'm even getting faster cost. So look at this. If you can't quite read at the bottom, but it says the time was 27 faster, but the cost is 41 cheaper. So in this workload, using a data-driven approach, if I wanted to use 3 gig of memory or I wanted to use 2 gig of memory, that's pretty kind of similar, I can see immediately by switching over to Graviton for this function, I'm going to have 27% faster invocations, and that's going to be 41% cheaper. Absolute winner. I'll show you, and if I had a better example over here, what you may actually be able to do is even right-size the memory for your Lambda function. So you may be able to reduce that function maybe from 3 gig to, say, 2.5 gig. So you pay less for your Lambda function, use less memory, and still be able to get the benefit of that price performance. So that's just a bit of a whiz through. I do apologize that some of the demos didn't work with the Docker kind of stuff, but I hope I gave you a sort of idea of how that sort of how that's meant to be working, and the different kind of things that you can do and use the Power Tuner to tune your results. Now, the next step on from this is obviously how I would move that into production. And so there are a whole ways which you can do with SAM and you can do with Lambda of using blue-green deployments. And that means that what you can do is you could deploy your Lambda function out, and then you can say, X amount of invocations or 10% of your traffic you want to go to your Lambda function. Have some CloudWatch metrics that you're watching in the background, and those CloudWatch metrics will make sure that you're comfortable. And as things are, as you can then sort of roll over that function basically from in. And you can be confident, really confident, that your function is not having any performance penalty. And of course, if there was any performance penalty with the blue-green deployments, you're able to simply roll back. So that's one way to do it. There are a whole bunch of different deployment mechanisms you can use using the code suite or using other kind of things. Gradual deployment SAM supports natively, which uses code pipeline under the hood. So that's a really cool way. Once you've done your power tuning, you get your results, and then you can move your functions over to Graviton and have some deployment mechanism to do that. So that is a sort of whistle-stop tour of some of the testing. I do want to just check what questions we have got in, but yeah, Sushant, Michael, any comments you have initially or corrections of what I was showing?
No, this is awesome. Thank you for putting that together.
I think it's super. I think if we need to do further performance testing, I think you've got a job, Julian. We might be reaching out to you.
Well, I can't do credit. Alex Castleboni is one of the developer advocates. He actually wrote the Lambda power tuning tool, and that is super useful. Forget even comparing ARM to Graviton. That is super useful. And in the chat, what I will do is I will put the link to that, so you can be able to use that for yourself. What else haven't we covered? Sushant, Michael, anything else you want to bring up for the last few minutes?
No, I think you covered everything.
Okay.
No, I think
cool.
There are customer questions, I think that's the only other thing.
Yeah, certainly. We did have a quick Luca who was talking about how does this affect other languages that are compiled, like Go. I'm not quite sure, Luca, apologies, because I was doing the demo. I'm not quite sure what you were referring to, but that's the same process for all kind of things. If you're doing something like Go, you are going to be able to compile your dependencies, and yeah, that's just the way you're going to be able to test it on exactly what we showed over there.
I think we referred to it earlier as well. Sorry, one call out is on the versioning of the languages that you're using. You're probably going to go for the same thing, Sushant. We did notice significant differences in the performance of the versions. So do test with the most recent versions of your runtimes that are available to you for the functions that you're trying to execute. Go 1.14 to 1.16 was one of those that we noticed a significant difference between. I think you'll see a big difference between Java 8 and Java 11 as well. So I think that those are worth call-outs. So with Go specifically, please do trial different versions.
Yeah, definitely.
The other thing to add onto that one is, in order to use Go with ARM64, you would need to use the custom runtimes. So you'll need to create that custom runtime to then deploy.
Yeah. And that, some people are a bit intimidated by the custom runtimes. Having played with it myself, it's actually not that complicated. I don't have the link immediately in front of me, but there are a lot of people who've created custom runtimes for Go. And if you create this sort of custom runtime shim, which is delivered as a Lambda layer or in a container image, and that's a one-off. And then every single time you can use that custom runtime layer across all of your Go functions. So it's a bit of one-time effort to use that. But if you do manage to do that, your Go functions, you can bump up the Go version to 1.16 to get a performance hit, improvement. Oh dear. But the cool thing is 2 things for Go as well. Using the customer, that means you can also use now this Graviton support, and also you can use Lambda extensions. So if you are extensions with Go, I would suggest it is worth looking at. That functionality. One other thing I've put in the chat is the Graviton Performance Runbook, and this is a whole lot of information that the Graviton team have put together. And this is, it lists a whole bunch of different software binaries and mentions things like Go and all that kind of functionality that has been improved for Graviton. So I think that's about it. Let me just mention for next week. Next week, when I was talking about the SDK integrations, that is happening live next week on Serverless Office Hours. Eric Johnson has lined somebody up, and he didn't tell me in advance, so I'm just calling them the workflow superstar, which I'm sure they will be. So next week will all be step functions and the new SDK integrations I spoke about last week. But thanks so much this week for Sushant and Michael. Really appreciate you taking the time to talk to us today and tell us all about Graviton. And as with all things AWS, we're really getting started. This is early days, and we're super happy to see how much support Graviton is having already. We're getting great feedback on Twitter and social media via TAMs, and direct feedback with Sushant talking to customers, how impressed they are with this Graviton support. So that's super kudos to Michael and the team for doing a great engineering job to make this as seamless and as possible for Lambda. So it is just a lot of it's happening underneath the hood, and there's some great performance benefits. And save yourself some money by having a look at Graviton and seeing how you can migrate. So thank you very much for joining us today. Until next week, enjoy the rest of your evening. Thank you and goodbye.
Thank you.